New heart that I segmented in between the time that I met with Max and company yesterday over at Toronto General and just a couple minutes ago. This is ITK Snap that I've been using quite a bit lately over a 3D slicer. Mainly because its ability to segment really quickly and really uh, automatically is heads and shoulders far above whatever other thing you can think of better than 3D Slicer has to offer. As you can see, the label maps don't really matter. You can make any number of label maps that you want. In this case, I've gone ahead and labeled the left ventricle plus the left atria as one huge blob, the right ventricle and the right atria as one huge blob, the aorta, and I have no idea what this is, honestly. Maybe you guys will. And of course, the endo and epicardium are just this blue shade. Why did I choose blue instead of red? I mixed up the colors. So what makes this really, really powerful is its ability to segment automatically. And as you can see, based on the image segmentation that it runs, uh, it's very accurate into what you are actually able to segment out. Like, if I was trying to do this in 3D Slicer, it would take me upwards of 18 to 24 hours easily. That was the first heart that I sent you guys with all the messy insides. This one took me about 8 hours maybe to fully segment and semi-cleanly and accurately too, because okay, so this is just the axial view that I'm showing you, but if we go into all three views, hopefully it doesn't crash on me again like it did last time. There we go. If we go into all three views, so up here, you can see that the detail in all of the planes is pretty good, and all the different chambers have been segmented quite well, I think. There was some manual changes to be done just to fill in a couple of gaps so that for instance, the right ventricle and the left ventricle didn't share a wall, so it looked like there was a septal defect or anything. As long as I gave it a little bit of definition and went through this kind of semi-thoroughly, I think it looks okay and fairly accurate, but you guys will have to double check. And in this bottom left window, you just see the final 3D model that you can export out. What's really, really, really good about this program too is that when you go out to actually export your surface mesh, it'll give you the option to export certain features only. So left ventricle, right ventricle, the musculature of the heart, the aorta. Of course, you just name these colors whatever you want based on your needs. But in this case, I've just gone ahead and labeled them like this. You can export meshes for all labels as separate files, which is exactly what it sounds like. All of those color-coded regions will be just made into separate STLs. Or you can just join every single color together as a single scene. And I've already gone ahead and exported the meshes as separate files. And I think the one I'll show you, and the one that's most pertinent to this entire discussion, is what happens when you export just the musculature. So forget all the inside stuff. It was just kind of there to help the automatic segmentation know where the boundaries are for the actual musculature, which is what you'll be most interested in. So here we go. I've already reduced this file size down from the original one. I think the original file had like 800,000 or up to 1.1 million triangles or something, and this one's down to about 500,000. So hopefully this doesn't crash and it loads. There it is. I've cut out a couple of regions that just aren't very interesting. I've made the bottom flat to make it easier to print if it comes to that, and I've chopped off a bit of the like the aortic arch over here, just so that you can see very cleanly where the aorta is coming from. As you can see, there's no residue inside, and where it's going to go out of, through here, through there. And what's really interesting is when we go to plane cut, there it is. There we go. All the chambers are now present. So you can follow the atria or the aorta all the way through, and it's not clipping anywhere inside the left side or the right side of the heart. You can scan all the way through, and everything up to here is completely manifold and printable. You can see the ventricles completely well defined, so this would be the left ventricle, right ventricle. There's the septum. It's a little bit skinny here. That's my fault probably, but it's defined. The wall around the heart is continuous now, so there's no weird elements that are just missing, or it looks like there's been parts of the heart removed. As we move up towards the atria, let's go start to see the formations of the right atria here and the left atria here. And again, the aortic arch is very well defined. As we keep moving up, it becomes even more defined, as you can see here, and I think that's the pulmonary vasculature as well. And if you want to see the four-chamber view, I think I can give you that. So is this model 100% accurate? Absolutely not. This still requires, if anything, a good look from you guys to say whether or not I'd missed some areas, which is almost a definite yes. But based on what I can see so far, and there we go, there's the four-chambered view. And we can scroll through this, and it's all printable except that area, but there. So this would just be the roof of the left ventricle, for instance. But we can just scroll past that a little bit, and there you go. Atria, right ventricle, left ventricle. Parts of the aorta are somewhere back there. You can see the aortic opening here, and the where the semilunar valve would be. I think it's semilunar. I have to admit my cardiovascular physiology is a little bit off right now. There. So it's more complete than either one of the two models that I've done so far, and this was done much faster as well. The surface features are pretty good. You can see some surface veins. There's some weird blobs here. That kind of comes with the territory for manual segmentation using ITK Snap. I can explain that a bit more later, but as you can see, the entire heart is manifold, and it is, for all intents and purposes, chambered and smoothed and printable, I think, except for a couple of weird places. Even if we go to the top view only, that's the heart. To show you how detailed you can get ITK Snap's automatic segmentation module to actually work, let's see. I can show you what happens when we export out the individual blood pool samples. So let's look at the aorta. So there's the aorta, the yellow thing that you saw in the ITK Snap window. So this guy over here, right there, flowing through here. And as you can see, this is where it would meet the left ventricle, which is in red. So, and you can also see these two bumps. And what those two bumps actually are, I think, would be the valve, or at least the outline of the valve. You can't really see it on MRI CT, but there are three very distinct bulges on the beginnings of the aortic arch, and I think those would be where the valves would sit. So it's in theory possible to print this heart with at least a slight outline of the aortic valves, or some facsimile of it. Some limitations, of course, you see some strange 90-degree angles here. That's a problem with the automatic segmentation, and it gets kind of hard to find these really, really small spots of imperfections once you're dealing with a model of this size and this far covered. But we'll work on it. So it's a work in progress. I'll upload all of the files onto the Dropbox. You can fly through the heart and all of the other segmentations, like this aorta or see the left ventricle. I guess it's mostly the left blood pool to be more completely accurate. There it is. It's just rotated. So it would look like that. Yeah. So let me know what you guys think. Thanks for listening.